In this video, I'm going to look at tangents to polar curves. We are only going to look at tangents which are either parallel to the initial line or perpendicular to the initial line. We know that y is equal to r sine theta and that x is equal to r cos theta. We also know that the gradient is always dy by dx. If we remember the chain rule, dy by dx is dy by d theta divided by dx by d theta. So if we're looking for tangents parallel to the initial line, we're looking for tangents which have a gradient of 0. We're looking for the case where dy by dx theta is equal to 0. If we're looking for tangents perpendicular to the initial line, we're looking for an infinite gradient. We're looking for dx by d theta is 0. Well, I've summarized that here. Tangents will be parallel to the initial line when dy by dx is 0. That means dy by d theta is 0. That's d by d theta of r sine theta. Perpendicular, d by d theta of r cos theta is 0. There's one point to bear in mind. If both dy by d theta and dx by d theta are 0, then dy by dx is 0 over 0 is not defined. If this is something which happens to you, you should look at a sketch, or there is a little device called L'Hopital's rule, which allows us to get out of trouble algebraically. Here we have an example just to show how all of this works. We have the curve r is 7 plus 3 cos theta, and we want the exact equations of the tangents parallel to the initial line and perpendicular to the initial line. Well, remembering that dy by dx is dy by d theta divided by dx by d theta, for part A, we're looking for dy by d theta is 0, and y is equal to r sine theta. R is 7 plus 3 cos theta, so that is 7 sine theta plus 3 cos theta sine theta. That's just r times sine theta. We now want dy by d theta. And that is equal to 7 cos theta. Now we have a product. Differentiating the sine, we get cosine, so that's 3 cos times cos, 3 cos squared. Differentiating the cosine, we get minus 3 sine theta times sine theta. We want to put this equal to 0. If we're going to solve that, we've got to remember that sine squared theta is 1 minus cos squared theta. Put all that together, 3 cos squared theta plus 3 cos squared theta is 6 cos squared theta plus 7 cos theta minus 3 is 0. Let's factorize that. 3 cos theta, 2 cos theta. If I do 3 times 3, that's 9. And minus 1 times 2, that's 7. Yes, so we get cos theta is 1 over 3, or minus 3 over 2, which is not possible. So we know that we have gradient 0 when cos theta is 1 over 3. We're looking for the equation of the tangent. That is going to be the value of y. Y is r sine theta, and at cos theta equals a third, r is equal to 7 plus 3 times cos theta is 8, and sine theta is equal to plus or minus root 1 minus cos squared theta, which is plus or minus 2 root 2 over 3. And so we are looking for the tangent y equals plus or minus 8 times 2 root 2 over 3, which is plus or minus 16 root 2 over 3. And this, in polar terms, is r equals plus or minus 16 root 2 over 3 cosec theta. Notice we were asked for an exact equation. We mustn't just press the buttons on the calculator. We must show where the sine theta value has come from. 1 minus 1 over 9, 8 over 9. Okay, so there's the tangents which are parallel to the initial line. Now for the tangents which are perpendicular to the initial line, we shall need x is r cos theta. R is 7 plus 3 cos theta. So that gives us 7 cos theta plus 3 cos squared theta. dx by d theta is 0 to give us an infinite gradient. dx by d theta is minus 7 sine theta, minus 3 times 2 is 6 cos theta sine theta, using the chain rule, and we want this to be 0. Well, we can factorize this easily. Sine theta times minus 7 minus 6 cos theta equals 0, which tells us that sine theta is 0, or cos theta is minus 7 over 6. That's not possible. Sine theta is 0 gives us theta is 0 or pi. So when theta is 0, we get r equals 7 plus 3 cos 0 is 10. The tangent, therefore, is x equals 10, which is r equals 10 sec theta. When theta equals pi, r is equal to 7 plus 3 cos pi. Cos pi is minus 1, so this gives us 4. The tangent, therefore, now this is where you've got to be just a little bit careful. 4 at an angle of pi will give us x is minus 4. And therefore, the tangent is r equals minus 4 sec theta. And this illustrates what we've just done. Tangents, y is plus 16 root 2 over 3. That's just over 5 root 2. That looks about right. And minus it. And there's the polar equation. And the other tangents are x equals 10, x equals minus 4. or r equals 10 sec theta, r equals minus 4 sec theta.